Friends, in this video, we are detailedly study what are the different natures of the load torques and what are the different classification of load torque. So let's begin. So friends, we will start to understand what do you mean by the nature of the load torque. So for the understanding of the load torque, you should know the basic fundamental concept of what do you mean by the load torque. So for your sake of understanding, I can again explain you what do you mean by load torque. So in general, we are having a different motor load combination. So this will be your motor, this will be your load. So this is called as the dynamics of your electrical drive. So as we know that according to the basic block diagram of your motor, that is the drive, the system employed for motion control, that is called as drive. If we are employing the electrical motors for motion control, this is called as the electrical drive. So this is called as motor torque Tm, this will be called as the angular velocity omega m, and this is called as TL. TL is called as the load torque, and the direction of the load torque is always opposite to the motor torque. Means motor torque's direction is upward, then the load torque direction is always downward. Why the load torque has its direction? Because if you want to lift a load, for example, we are using the induction motor for the pump purpose, then obviously the motor torque of the induction motor is in positive direction, so obviously the load torque is in negative direction. So these both torques are opposite to each other. So the load which is called as pump, and this load has a torque, that torque is called as the load torque. Now we want to understand which type of the nature that the load torque possesses. Means the nature of load torque. Nature of load torque, in which its components are differentiate along its value. So now we can understand the basic concepts of the nature of load torque. I think everyone has got the clear idea what do you mean by the load torque. So the basically the nature of the load torque is dependent on its a particular application. So in industry there are n number of types of applications for your drive, for your motor. So the nature of load torque is basically dependent on very important parameter, that is the nature of its application. Means if you are using any type of motor, such motor will be called it as DC series motor used for the traction purpose, then its nature is different. If we are using a DC shunt motor for the lifting of the constant speed variable, then its nature of the load torque is different. So we'll start to discuss how the nature of load torques are differentiated. So the first, that is torque is constant. The nature of load torque, in the first case it will be constant. So what do you mean by the torque is constant? So obviously it will be the independent on the speed. If the load torque is the independent on the speed, so obviously at that time the load torque is obviously constant, and this the load torque is obviously constant will be shown by the different characteristics we will study, that is particular characteristics. So the second type of nature of load torque is called as torque is a function of speed. Torque is a function of speed means what? While we are changing the value of the speed, then the torque will be either increasing, either decreasing, or maybe constant. So that will be dependent on the function of speed. So the nature of torque, that is the load torque, is basically have two types. That is the first nature of load torque is called as torque with a constant, that is the independent on speed, and second one type of torque is called as torque is a function of speed. So guys, we will start to discuss the first, that is called as torque is constant, that is called as independent on the speed. So guys, in a day-to-day life we are using the different types of loads for different types of the application. So most of the working machines that have the mechanical nature of work, like shaping machines, cutting machine, grinding machine, require constant torque irrespective of the speed. Guys, this is very important function in which we are using torque is constant. So these applications are called as the various mechanical work. Such mechanical work may be your shaping of your machine, maybe cutting of your machine, maybe grinding of your machine. It will require constant torque irrespective of speed. So such the nature of torque will be shown by this graphical method. So such kind of nature of graph will be graphical method, in which obviously the load torque is constant, which will be shown by the straight line, because this will be the plotting of the torque versus speed characteristics of your drive used for the particular application. So obviously in that particular figure, if the torque is constant, so obviously we are getting the value or the line, that is line which is obviously constant for your load torque, and this will be the one of the nature of your load torque. So the first method in which the load torque is constant, and which will be indicated by this straight line, and such kind of the torque is constant is used in a mechanical work which is called as shaping, cutting, grinding, turning. Along with that, in a day-to-day life, such kind of nature load torques are available in a crane, hoist, in a conveyor belts, and in a paper mill. So as these are the various examples in which we are using the nature of load torque is obviously taking a constant, means it will be independent on the motor speed, and this will be the representation of the torque is constants, that is the independent on the speed. Okay, so this will be the first nature of your load torque. So after that we will study the second type of nature of your load torque. So the second type of nature of your load torque, in which obviously the torque is the function of speed, means what? The value of torque is basically increasing, that is torque is dependent on the speed. So first case, that is torque is directly proportional. When, what do you mean by the torque is directly proportional? If we are increasing the value of the torque, then the speed is obviously increasing, that is the speed is increasing. It is the first method, that is torque is proportional to the square of the speed. So in this method, while we are increasing the value of the torque in terms of the square of the speed, so this relationship is shown by this graphical method of torque and speed, in which we are getting the value of curve of your torque in concern with the square of speed. Basically such kind of load has a low starting torque, and the example for the torque is a function of speed, that is the square of speed. Basically this is called as torque is a function of the, or torque is directly proportional to the square of the speed, has used in a different axial and centrifugal pumps. Then we are using at a centrifugal compressor, we are using at a different fans condition. Similarly, we are using such kind of application in a ship propellers. So such kind of the nature of load torque, which is basically torque is proportional to the square of the speed, and such kind of applications are pumps, compressors, different industrial fans, and the ship propeller. So this will be the one of the function of the speed. So what will be the function of the speed? That is torque is proportional to the square of the speed. Okay, then the second function now we considered, that is second function is called as torque is linearly proportional to speed. Linearly proportional to speed means torque is linearly proportional to the speed. So this will be the shown by the graphical method. This will be the speed, this will be the torque, and the proportionality line is linearly. So this will be the proportionality, that is called as torque is linearly proportional to the speed. So this will be the indication, and such kind of load torques are used in different types of mixers and different types of stirrers. What do you mean by stirrers? This will be the diagram of stirrer. So in the stirrer mechanism, obviously the torque is linearly proportional to speed, means by means of the pushing that particular switch, the rotation of that stirrer is getting rotating, means in that particular application the torque is directly proportional or linearly proportional to the speed, and the curve for such type of stirrer or such type of mixers are shown here. So this will be the second one of the important parameter in concern with the load torque. Okay, so after that we will discuss the third type of torque, that is the nature of third type of torque, in which we are getting the torque is inversely proportional to the speed, means the torque is inversely proportional to the speed. So what do you mean by the torque inversely proportional to the speed? Means if we are increasing the value of the torque, then the value of the speed is decreasing. If we are reducing the value of the torque, then the value of the speed will be the increasing. Means the relationship of torque and speed will be inversely proportional. And this the torque and speed inversely proportional is shown by this graphical method. So in which we are getting the graph that is inversely proportional. Okay, so such kind of the torque is inversely proportional to the speed. Basically in that particular torque the developed power is nearly constant and it is approximately hyperbolic in nature. So this will be shown by the symbol of hyperbola. So it will be hyperbolic. So such kind of the torque is inversely proportional to the speed. We are using such kind of the applications are called as lifts, lathe machine, that is mechanical turning machines, then wire drawers. The wire drawers are used to draw this wire from the stakeholders, and the next application is called as winder in industry. And similarly the torque is inversely proportional that we are using in the reciprocating rolling mills. Obviously torque is inversely proportional to the speed, and this will be the nature of your torque. Okay, so in this way guys we have understand the different types of or the nature of the load torque. So again I can repeating what are the different types of the nature of the load torque. So the load torque has a different two types of nature. First one is constant speed, constant speed. Second one which is called as the dependent on speed, dependent on speed. So in dependent on speed there is three possibilities. First possibility is torque is proportional to the square of the speed. Second possibility is torque is linearly with the speed. And third possibility of the nature of torque is inversely proportional to the speed. So this is called as the nature of the load torque of your electrical drive. Okay, so we will start to understand the very important concept of in concern with the electrical drive, and this is called as classification of load torque. So friends, in university examination such kind of question is basically asked for the 5 marks, and such question is called as the draw and explain the different classification of load torque. So guys, again the concept of load torque, the load torque is this will be the motor, this will be your load, this is called as motor load combination, this is called as motor, this will be called as load in an electrical drive, that is dynamics of drive. This is called as Tm, this is called as Tl. It will be rotating at a speed of omega m, and this TL is called as the load torque. That is load torque is basically dependent or directly coupled to your motor. And the classifications of such a load torque, the classification of such load torque, it has two different types, and these two different types are shown here. That is the first type of classification of load torque, and this will be the second classification of load torque. So the first classification of load torque is called as the active load torque, and the second type of classification is called as the passive load torque. So we will start to understand what do you mean by active load torque and what do you mean by the passive load torque. Basically, the name itself indicates its meaning, but for the sake of understanding, let's begin to start the basic concept of the active load torque. So what do you mean by the active load torque? First of all, we can understand the load torque which has an the addition the potential to drive the motor under equilibrium conditions. Such drives or such load torques are called as the active load torque. Means what? Active load torque has a potential. Means such kind of load torques which are having a potential to drive the motor under the equilibrium conditions. Means what? Suppose we are starting a motor from the starting end condition with the means of the starting of your motor, then such kind of load torque is called as the active load torque. Such load torques are retain their sign when the drive rotation is changed. Means obviously the active load torques are retain their sign when the drive rotation is changed. Means the speed of your drive is changed, then it retain its sign. So such kind of active load torques are called as the different types of active load torques. So the example for the active load torque is called as the torque due to the force of gravity, the torque due to the tension in elastic body, the torque due to the compression and the torsional speed. Again guys, I can explain you what do you mean by the active load torque. Active load torque means what? So if the load torque has its own potential, means such kind of load torque have its own potential to drive a motor, okay, under the equilibrium condition. Okay, so such kind of load torque is called as the active load torque. So the best example for the active load torque means what? It has its own potential to drive the motor under equilibrium condition. And the example for the active load torque is obviously the force due to the gravity. So obviously the gravity have its own potential to drive the motor from the equilibrium condition. So that will be the one of the example of force of gravity. Second, tension in body. Means obviously if we are compress one of the body in terms of the tension, okay, suppose one of the elastic body is there and we are getting the tension in that particular elastic body, so obviously it has tendency or it has the potential to drive from the equilibrium condition. So that will be the second example for the active load torque. And the third, that is the torque due to the method of compression or torsion. So the meaning of compression and torsion, it has the potential to drive the motor from the equilibrium condition. So these are the one of the example of the active load torque. Okay, so let's will start to discuss about the next type of load torque. This is the name itself indicates it is a passive load torque. So what do you mean by the passive load torque? The load torque which always opposes to the motion are called as a passive load torque. So what do you mean by the passive load torque? Such kind of passive load torques are always opposes the motion, always opposes to the motions. Means what? Such load torques change their sign when the drive rotation is changed. What do you mean by the change of sign when the drive rotation is changed? Means what? If the direction of rotation is changed, means before it has the positive sign, then after the change in the direction it will show you the negative sign. So it will change their sign when the rotation of the drive is changed. So such kind of passive load torques are available due to the friction, the torques due to the cutting, the torque due to the windage, and torque due to the lathe machine, because the lathe machines are basically used in a different cutting, tooling and shaping operation. So in that particular application we are having the value of the passive load torque. So again I can repeat, what do you mean by the passive load torque? The passive load torque is called as the load torque which will be having the capacity of the opposing to the motion. So such kind of motions are opposes. Suppose a motor will be rotate in a anti-clockwise direction. So by the means of that particular passive load torque, it will be opposite that particular motion in a clockwise direction. So such kind of load torque is called as the passive load torque. And such kind of passive load torque having changed their sign. Suppose this will be the positive sign. So after this type of load torque, the sign will be the changing, that is a negative load torque. And the application of such load torques, that is torque due to the friction, torque due to the cutting, torque due to the windage, and torque in the different lathe machine, because lathe machines using different shapers, different cutters. So such kind of load torques are called as the passive load torque. So guys, in this way we have detailedly studied about the various classifications of the passive load torque. So thank you.